Okay, let's continue on with page 7 of the differential equations packet. Before I do that, though, I want to come back to these 5 steps for solving differentiable equations, and actually I want to add a sixth step. And we did this already, but we want to find the domain of the function. Quite often they're going to ask us to do it, so it'd be good to go ahead and just get in the habit of doing it. Okay, before we move on, I want to just talk about this statement right here, exponential review, and take a look at y e to the x plus c is equal to c e to the x. So we go back to exponentials for just a second. When we're adding exponents, I can take e to the x plus c and rewrite that as e to the x times e to the c. Because if the bases are the same, then when I multiply powers, we add exponents. Now, I'm going to use the commutative property here to swap the order of these and write it as e to the c times e to the x. Now, e is a constant, c is a constant, therefore e to the c would be a constant, so we can write that as c e to the x. Now, what might be a little new to some of you is the idea that I'm using c here to represent one number, while down here c represents an entirely different number, most likely. Most of the time in algebra, whatever number the variable represents, it represents that number throughout the entire problem. In this case here, though, c represents more the concept of a constant rather than a specific number. So if we're going e to some constant, what we're going to get is a constant times e to the x. Okay. All right, let's take a look at example number 23. It says, consider the differential equation dy dx equals 2 times x times y. And right off, we should note that this is a product of 2x and y, so this is separable. Find y equals f of x, the particular solution to the differential equation, with the initial condition that f of 0 is equal to 3. State the domain of the solution. So let's go ahead and do that. dy dx equals 2xy. So what we're going to do is we're going to go ahead and multiply both sides by dx while dividing both sides by y, or multiplying by 1 over y. So on the left, I get 1 over y dy, and on the right-hand side, I get 2x dx. Now we integrate both sides. 1 over y dy equals the integral of 2x dx. On the left side, the integral of 1 over y, the antiderivative is the ln of the absolute value of y, equals, and the integral of 2x dx is going to be x squared plus this constant. Now we're told that when x is 0, y is 3. So let's go ahead and do that. I have the ln of the absolute value of 3 is equal to 0 squared plus c. Since 3 is positive, the absolute value of 3 would be 3, so we can just write that as the ln of 3 is equal to 0 squared is 0 plus c is c. So our constant is going to be the ln of 3. So now we come back down here, and to say that this is the ln of the absolute value of y is equal to x squared plus the ln of 3, our constant. Now to solve this for y, we need to go ahead and exponentiate both sides. So therefore I'm going to write it as e to the ln of the absolute value of y is equal to e to the x squared plus the ln of 3. On the left side, the e and the ln cancel, and I get just the absolute value of y. On the right-hand side, we're going to do what we did on the other page, which is if it's e to the x squared plus the ln of 3, then I can do it as e to the x squared times e to the ln of 3. So let me go ahead and write that. It's e to the x squared times e to the ln of 3. But e to the ln of 3 is just 3 because the e and ln cancel, so I get 3e to the x squared. Now in this case, because the absolute value of y is equal to 3e to the x squared, then y could be 3e to the x squared, or it could be negative 3e to the x squared. So I need to ask, so I'm going to just go ahead and branch it here, is it y equals 3e to the x squared, or is it y equals negative 3e to the x squared? To answer that question, we need to go back up to this initial condition, 0, 3, and ask, when I plug in 0, which of these two functions contains the point 0, 3? So on the left one here, 0 squared is 0, e to the 0 is 1, times 3 is 3. That looks good. On the right-hand side, 0 squared is 0, e to the 0 is 1, times negative 3 is negative 3. So therefore, our function is going to be y equals 3e to the x squared. Finally, what's the domain of this function? Well, the domain of this function, because it's e, the domain is going to be negative infinity to infinity, all real numbers. Right. Let's take a look at example 24. It says consider the differential equation dy dx is equal to y plus 5 times x plus 2, and again a function in y times a function of x. So this is separable. Find y equals f of x, the particular solution to the differential equation with initial condition f of 0 is equal to 1. State the domain of the solution. So again, we're going to go ahead, we're going to divide by y plus 5 and multiply by dx. So I end up getting 1 over y plus 5 equals x plus 2 dx. Now we integrate both sides, and that should contain a dy over here. So 1 over y plus 5 dy equals x plus 2 dx. We're going to integrate that. So this becomes the ln of the absolute value of y plus 5 equals 1/2 x squared, or x squared over 2, plus 2x plus c. So now we use our initial condition of when x is 0, y is 1. So I have the ln of 1 plus 5 equals 1/2 times 0 squared plus 2 times 0 plus c. The left-hand side, 1 plus 5 is 6. The absolute value of 6 is 6. So we just get the ln of 6 on the left. 0 squared, 0. 0 times 2 is 0. Plus c gives us a constant of ln of 6. So let's substitute that value in for c. And now we'll solve this equation. To solve, to get rid of the ln, we're going to exponentiate both sides. So e to the ln of the absolute value of y plus 5 is equal to e to the 1/2 x squared plus 2x plus the ln of 6. On the left-hand side, I get the absolute value of y plus 5 equals, I'm going to jump a quick step here. This is going to be e to all of this times e to the ln of 6. E to the ln of 6 is just 6. So I end up with e6 times e to the 1/2 x squared plus 2x. Now again, y plus 5. The absolute value of that is this. So y plus 5 could be 6e to the 1/2 x squared plus 2x, or it could be negative 6e to the 1/2 x squared. So let me just, again, we'll write that. Y plus 5 equals 6e to the 1/2 x squared plus 2x, or does y plus 5 equal negative 6e to the 1/2 x squared plus 2x? To answer this, we have to ask the point 0, 1, which is our initial condition, is on which function? So again, let's just run through. Plug 0 in here, this entire new exponent just becomes 0. So e to the 0 is 1. So I get y plus 5 is equal to 6. And if y is 1, I get 6 equals 6. That looks good. Over here, if I plug in 0, 0 squared plus, or times 1/2 plus 2 times 0 gives me 0. E to the 0 is 1. That gives me a negative 6 on the right. Well, when y is 1, 1 plus 5 is not negative 6. So our function is the one on the left. Now I've got to finish solving for y. So I get y is equal to negative 5 by subtracting the 5. Negative 5 plus 6e to the 1/2 x squared plus 2x. The domain because again, the function is an E function. The domain is going to be all real numbers. So the domain is negative infinity to infinity. And that's it for example 24. We'll do the last 3 examples in the next video.